Hello, everyone. I think I should have changed my talk to machine learning on Kubernetes, but I'd like to start with you to say why am I here, why am I giving this talk at this place. First, yeah, it was my first day in Istanbul yesterday, and indeed, I had my first donor, I would say, because the ones in other sides are not real donors, I would say now. But so to talk a little bit about myself first, yeah, I like to eat, as you can see, but I also like to cook a lot. I like to play the guitar and piano with my daughter. And at the same time, I might say that I'm not this precisely a software engineer by formation. I studied theoretical math at university, did my master around that. And after some time studying differential geometry and seeing that calculating negative surface of stuff didn't add anything to my life, I jumped into software engineering. And anything data, I probably done it. So database administration, data science, data engineering, data, blah, 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 whatever name, when people want to come with it, anything related to data, I probably have done it. I helped organize DevOpsDays Amsterdam for a few years together with Mine, that's here. And I also organized some other events and all of the things that I like to do, but my wife hates because I do it for free on my spare time. And I work at LINKIT in the Netherlands. And what I do there, I'm the head of solutions engineering. That means nothing. That just means that I help companies develop solutions, usually on the data field. So if a company has a problem or something that they want to fix, or if they want to dream about something related to AI, machine learning, or anything to it, I usually come into it, I help them. And I must say, 99% of the time, the problem is getting the right data in the right place at the right time. The algorithms and the ArcVix papers and all of it, I keep track of some of them, because there are 100 of them coming out every day. But I rarely use something more fancy than linear regression and the majority of the stuff that I do. When it's very, very complex data, I use deep learning and things into it, but all the things are already built. And as a company that does solutions for other clients, I get a lot of things like this. Clients coming to me and just saying, can you also do something with this TensorFlow thing or whatever, or make a phone call so I can have a very nice press release and say that we are an AI company. And usually somebody on that same meeting comes with all the other buzzwords. Can you use blockchain and do something different with it? And of course, the ultimate medium reader, dev.to, blah, blah, blah person come with this buzzword bingo kind of solution. AI, DevOps, Cloud Native, App, Kubernetes, Blockchain, Back, IoT, AR, Red Set, and with digital transformation. And I say like, sorry, I don't work with that. I need something tangible and feasible to actually help you with. Nowadays, I'm hearing a lot of service mesh as well. I think Istio has something to do with it. And usually this person that wants to talk about it, they actually get funded, move to the Bay Area and all of it. But I'm like, okay, you're here to talk about AI, DevOps mindset, what does this has to do? We are in a DevOps conference. DevOps started officially in Ghent almost 10 years ago. October 29 now, it's the reunion in Ghent in Belgium, really, really close to the Netherlands where I am. And it started to try to fight this timeless conflict. So to give you some context into this, who here works directly with machine learning? I would assume no one, but one person? Who else? One person, okay. Who here is a DevOps engineer? And I'm putting in quotes, okay. Who here is a cloud engineer? A developer or product owner? Scrum master? Is there anybody that is not any of these things that I mentioned? No? Okay, good. Who here already worked with putting machine learning models or anything related to machine learning in production? One person? Two? Two people? Okay. But I assume that you all deploy something in production that is not machine learning, right? So the DevOps movement came to try to sort it out, this timeless conflict. And what is the timeless conflict that it mentions? Developers are measured and scaled by features that need to be deployed, bugs that need to be fixed, and things that you have to solve for a client. That is what they're paid for. You need to generate more things for my client so he is happy. So I'm the sales guy. I go into there and say, like, we're going to do this amazing feature. We're going to pay $1 extra, and it's going to be available. I come to the development team. I build the user stories, the acceptance criteria, the definition of done, blah, 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 blah. You try and you work with it. In the same time, more than 10 years ago, but of course it happens a lot still, there was the operations team that had to manage that and make sure that the service was available. Just like we saw now with Berkay, OpsGenie has the 5 nines. So there are people working at OpsGenie to make sure that OpsGenie is stable and working with 5 nines of SLA. What if I told you that you got measured and paid by these 5 nines while the other one got measured and paid by the speed that they develop new stuff? These two contradictory goals, these two contradictory measurements between development and operation generated this conflict, this downward spiral. I want you to move slower because I don't want to be woken up. I don't want to be wake up in the middle of the night because something went down. While the developer wants to move faster because he wants to test the new version of Vue, for example. This conflict came in a sense that you always had problem. You started to have a slower time to market. New products and new features would take more time. You start to have reduced quality. You increase the number of outages. And worst of all, you start to have an ever-increasing technical debt because developers and operations would start to cut corners to make sure that their goals were met and the things that they were measured were accepted. One of the solutions that the DevOps movement came into it was, why don't we work together? Why don't we work in a product team in a more centered way so it can have a smaller loop? Why don't we put product development, IT operation, QA, and InfoSec into the same goal? Why don't we align them in the same direction? And this was supposed to be peace in the galaxy. Everybody would be happy. We would all go into this direction. But as everything that has a good start comes with marketing and things involved, so it started to come DevOps tools and certifications and frameworks and people selling DevOps and implement DevOps and let's do the DevOps and all of this stuff. And if you ask the people that started and the people that are working on it, there is no formal definition of what DevOps is. And it should remain that way because this should change. So what this has to do with what I'm going to say here is that for me, software development in general has become better and better in the last years. Of course, you still struggle depending on the company. I would hope that you, especially on the culture part, but for the machine learning thing, it's kind of a big struggle yet. But to go on with it, I like to make my own point. What is AI for me when I'm talking about AI? AI is making computers capable of doing things that when done by a human being would require like some kind of intelligence. And machine learning is something inside it. It's something that is related to make machines find patterns without explicitly programming them to do so. What I mean about that is that if I take a picture here and I put into AWS recognition, for example, it will probably tag conference room or something like that. There is no if and else algorithm there telling if the pixel number 37 has R value equals to this, green value equals to that, and blue equals to that, it's a conference room. No, it's a mathematical approximation based on a trained and labeled data set that we're passing to this, and it has an error. So it tries to find patterns and try to label that patterns and identify it. So, and this is a lot different of what we are used to develop. Developers usually work with if-and-else loops and functions. So when you are doing something, when you are building a feature, you work with counters and for loops. If you are functioning, I know that you step away from it to use different methodologies, but you are all going into this direction of trying to identify something, a counter, a variable, add values to it, do something, output into that, and solve it. We all know that this can be dragged down into this decision tree, kind of like. Have a specific decision, a specific if and else. If that, you compute here. If not, you go into this other one. And you can go into this infinite decision trees. This is how regular software is built. And this means that if there is a problem, you build an application, and that application goes into production, and there is an error at some point. It's not easy debugging, but you can sometimes pinpoint, I have a problem on that specific sequence. Then you can go there, patch that thing, and move on. That is how we debug, we test, we do a lot of stuff. And then, probably, if you are with time and you have the pressure and you know it, you're going to write a unit test on this specific sequence for the next time that you build on your CI pipeline. That unit test will cause similar type of errors. This is how traditional software development works. Machine learning development, on the other hand, works based on two things: data, what comes in, and hyperparameters. And what I'm going to talk about hyperparameters is every machine learning model, even a simple linear regression, it has a mathematical algorithm behind, getting data, calculating a differential, comparing against something, and you can tweak the hyperparameters of it. Just a simple linear regression, you can say, let's pick it up a ridge regression or a lasso regression or whatever. You can tweak hyperparameters. Some machine learning models have one hyperparameter. Some machine learning models have millions of hyperparameters. So what do? You start to fine-tune that. You start to go hyperparameter tuning. You start to exploring, what if this is 0.1? What if this is 10? What if this is that? And you start to calculate errors and comparing one model against the other. Why am I saying this? Is because some people may think it's mathematical magic. The magic that happens is actually building that algorithm that accepts these parameters. And that is what 1% of the machine learning engineers do in the world. The majority of the machine learning engineers, they already pick it up an algorithm that exists and is already implemented in Keras, in TensorFlow, or in PyTorch. They just tune the hyperparameters, add an input data, and start working with it. The problem is, if you have a deep learning network, for example, with just, 6 layers, 6 things in between, it's not a very deep one, you can have millions of hyperparameters. And that computation takes hours, days, depending on the laptop that you're using. So that means that if you want to test 10 different models with 10 different hyperparameters, you may last 2 weeks, 3 weeks, and it costs a lot of money. So the experience and the art of knowing, oh, this kind of data set, this kind of data points work well with this algorithm, you build with experience. And that's why experienced machine learning engineers are so expensive, because they know how to avoid the waste of money. But the thing is, this is very, very similar to a Kubernetes manifest. You don't have to specify how the algorithm is going to run. You just have to give an input and the hyperparameters. And this is brilliant. This is how machine learning development works. So you have this new life cycle now, like I'm saying. Inputs, hyperparameter tuning. It's a little bit different from traditional software engineer, but not that much, because now it always starts with the data. With the data, you usually go with a manual ingestion process. And with that manual ingestion, you have your first data pipeline. And why manual at first? Because there is the data science part. You don't know if that is going to work out. There's usually a funnel here. Some ideas will end up in production, some will not. So you have to know exactly when you are going to change that manual ingestion into an automatic one. And that's usually when you have a business case into it. So you do that ingestion and you start to explore the data. You start to clean it, to extract features from it. You may have a data set that has Number of sales per hour. Do you want to get precisely per hour? Do you want to accommodate that in chunks of evening, afternoon, and morning? How do you want to cluster that? So this is the feature engineering part, is generating new features by picking up what you have and combining them and doing things into it. By generating new features, you start to create some nice things, but also some problems. Have to know how to work with it. So after you do this, and you see like, oh, there is actually something that could help my business here. I start doing my model development. I train my model, I tune it, I test it. I train it, I tune, I test it. I test different models, I test different hyperparameters, I test against a separate data set. That's okay. I have something that can be used by the business side, and that comes into the point that usually people should do the automated ingestion part. And what happens usually is the majority of the data science machine learning engineers that I worked, they consider this the end of their job. They have a PPT presentation or a keynote or something. They present to their bosses or to everyone around the company. It's like, hey, I can generate this on my laptop. It gets 90-something% of accuracy. We're all good. We're going to make a lot of money on this. I'm going to jump into this next project because all the other things here are not that important to me. And this is usually what happens. And this is a very good concept of technical debt to me. People have to hack around that and start adding context and things and stuff to it until it actually explodes in someone's face. When you leave somebody to do something that you built from scratch, and that person has to take that and put that into production, that is a huge problem. And that is usually happening because people think that their job ends here, and that is not true. Their job move on, and it's never ending. A machine learning model is a product. A machine learning model is an API call, is an RPC, whatever. Your machine learning model needs to be packaged, it needs to be deployed, it needs to be operated, monitored, tested, logged, served. All of this are relevant things. We have to step away from the mindset that data scientists and machine learnings are wizards, mathematical wizards doing something on their laptop into they are a part of a team trying to add value to the company overall. And this is the mindset change that the DevOps world brought already to operations and developers and QA and InfoSec. And as someone that has been, I think, part of the movement of the DevOps, seeing this and also working on the data side, I think like, okay, we have a lot to drink from this source. We have a lot to do. And I've been trying to do that into companies, and surprise, surprise, the biggest problem is always the culture. Like, it's not about tools, it's not about the problems. Tools can help you a lot, but the problem is always, always the culture. And the main thing that I see is that nobody wants to be on call. Who here likes to be on call? Who here is on call now? Yeah, poor guys. I'm also on call. And nobody likes to be on call. Nobody wants to be on call. But developers will only build better code if they have the pain and experience of being waking up 3 a.m. because they put something to production that was not properly tested. Data scientists will only build and test code, treating as code, committing things into Git, when their API that results by their model is something that they break because of they miss a test or something, and they have to experience that pain. So I bring that culture to my team and to everyone that I worked. I lose sometimes good data science, good machine learning engineers, and good developers because of this, because everybody on my team needs to be on call. Everybody's part of the rotation. It's part of the culture. If you don't want to be part of that culture, you're not going to work at my company. That's how life goes on. You don't need to agree with it. The other thing that I see a lot is explainability and ethics. On machine learning and data science, we have this big problem with explainability and ethics. Meaning, if you are a machine learning engineer, or if you are a software engineer, that you are building a part of a software that is assessing what is the risk of somebody defaulting in a mortgage. Do you want to tell that person that she didn't get the mortgage because your algorithm said so? Or do you want to give that person input about what she can improve, what that person can do to become better, in a sense that how it can plan for the next year to actually have the mortgage accepted? Do you need to be able to explain that? How are you going to make that? This concept of explainability is a lot related to ethics in machine learning, and it's a tough thing to measure. And, of course, efficacy. Let's say that you build the hot dog or not hot dog app from the Silicon Valley. You have this picture, people put into a food and tries to identify if the food is a hot dog or not. How do you know that app is working or not? You cannot ask the end user every time that he uses to be like, was I correct or not? That is not how it works. You have to use proxy measures around it. You start a recommendation engine. After I put that into production, are people buying more? Are people buying what they recommended? Is the size of the basket increasing? So measuring efficacy of the machine learning things is a lot related to measuring things around it and the business effect of that implementation. And another problem that I see a lot is a lot of local development, local data, resulting in a lot of rework. What I mean about that is data scientists usually download things into their laptops, their CSV files and all of it, and they work with it. Mainly not because they're bad actors, mainly because there is not a good platform set up for them, because they are sometimes one or two, and they're new, and they are brought in after the train is already running, and things like that. So this generates a lot of rework, and I'm going to explain a little bit more why. So to fix these problems, and to make machine learning and data science a little bit more profitable for companies and more useful, because I see machine learning and AI becoming what big data was 7 years ago. Everybody talking, everybody investing, everyone build Hadoop clusters, but nobody getting return of investments. This is happening a lot in the machine learning world. And this has to do with, there is no silver bullet. There is no silver bullet. If I had it, I would be extremely rich now just doing consulting on this. And we have to change the way that we work. We have to change the way that our culture approaches. We have to include the machine learning engineers and the data science into the product team. We have to treat it as a product. And we have to stop saying, this data science work for the finance department to try to find something on this finance data. Give them a clear question. Give them a clear product. Give them something to build on. And one important thing, local data science is dead. And when I say about local data science is dead, is that, ooh, I'm doing local data science, I should be ashamed. No. But if somebody is starting a company now and planning in 5 years to be doing local data science, you are doing something wrong. Because why should we avoid local stuff? Again, something very, very much related to the culture. The majority of the data science and machine learning engineers, they come from an academics background. They have a master's or a PhD, and they work in physics or mathematics and other things, and they come into this field. Coming from that background, they are very much used to the concept of writing an article or something, submitting into a publication, and getting peer review. And this peer review for these magazines are incredibly detailed. If you have a model that is 93.4% accurate, and somebody has something a little bit better or a little bit worse, you get neglected. Like, no, this is not published because this, or this methodology is missing this or that. For the business, who cares? If you have a model that is 20% accurate and can be deployed into production now, then it's a business decision if that goes into production or not. This different mindset of how much value does a model with 80% accuracy adds to no model at all, that's a business decision to be made. And that has a lot to do with the failing culture. It's okay to fail. It's okay to build models that are 50% accurate, just like flipping a coin. It's okay to do this. Building this fail-safe culture is one of the most important concepts of DevOps and has a lot to do with this, because local data science usually happens because they download the CSVs, they do SQL queries, they put things in their laptops, they spend 3 months working into a model, and they only commit to Git 2 times in 3 months. Can you imagine a developer with 2 commits in 3 months? This happens a lot with machine learning engineers and data scientists because they don't want to commit what they don't think it's good enough. You have to tell them, publish, commit everything into it. Push everything into it. If you have a model that is 1% accurate, put it there. Why? Because somebody else will not try to do that again. It's all about the learning, and that's why local data science needs to stop, because people should be able to share and to publish things that they do. Another thing, yes, I'm from the DevOps world, so yeah, CI/CD for machine learning. And CI/CD for machine learning does not mean that things should be continuous delivery. Let's go into production as soon as released. No, it's a deliverable artifact. Things should be in a deployable state, and that's the important thing. And of course, like I said, we don't have regular bugs in machine learning. It's not hard, it's not easy to identify. But we have 3 things: bias, drift, and fragility. Bias is usually on the data set. Having bias things like Amazon had a hiring tool that used machine learning that was really biased towards women in tech. And that is a big problem because first, the data set didn't have gender information, so it gets bias on gender based on other features. So there are ways of solve that. Drift and fragility, on the other hand, are when things are running in production already, your model is interacting with the end user in such a point that your model starts to become worse. You have a recommendation engine. You never had one before, and now people are using and buying based on a recommendation engine. So maybe the features that you trained are not enough anymore to sustain and have a 90% accuracy. It starts to go to 98, 97, 96, 95, and it starts to become more fragile. So we have this concept, and I just need to speed up a bit, that I mentioned some things here: invisible work, speed, waste, collaboration, fail culture, and the concept of observability. Like, how do you know if a machine learning model is working or not? You have to measure, you have to observe. All of these things are a lot related to the DevOps world. And these are the things that I've been trying to push everyone for the data science and machine learning to use it. And for DevOps people to actually onboard the data science and machine learning into their teams and start building products, because everybody wants to work into this direction. So I hope that I could not say more, but there are some tools to help that I'm going to send to you. And one thing, do not reinvent the wheel. Use open source software as much as you can. And that's it. If you have any questions, I'm 30 seconds above, but I think we have some time. Thank you very much.
Thank you, Thiago. So we do have one question in SiliConf. So the question is, how do you handle unstructured data and predictive model that does not account for the real-time data in machine learning deployment? I'm also reading one time.
How do you handle unstructured data and predictive models not account for? Okay, who asked this question? Because I just need some clarification. What do you mean, how to handle and predictive model that does not account for the real-time data? Yes. Because this sounds like two separate questions to me, but...
Actually, you have historical data for ML deployments. But one time there is an unstructured data and unpredictable state. How do you handle that state? You fail or you
But
have some
that is during the inference part or in the training part?
it's on the deployment.
Yeah, but
Stages.
the deployment of the inference part of the model or in the serving part of the model?
Serving.
Serving,
Yeah.
okay. Yeah, so
Thank you.
So usually when you have unstructured data coming into your serving, you need to have an API first that is going to do a small transition from that into what the model needs. And that is usually a big problem if you have latency issues. Like, I need to do this in 10 milliseconds, otherwise my user is going to take a lot of time into that. Then it's a big problem. And I assume that this probably happened because the model was built on batch, and you now want to implement it on a real time. And usually you have to retrain your model to be built on real time. There is no easy solution to this. No, unfortunately not.
Any other questions? One more. Okay, one of our organizers is asking a question.
Okay, thank you. And I would like to ask you, how do you handle like streaming data and machine learning in real time in these operation situations? Like, how should an operation guy handle the issue of handling the streaming data? If there's like any new deployment we have to do while there's always the data streaming going as well.
Yeah, so yeah, usually like I said, there are two things when you're doing machine learning models. You have the inference part, that is actually training the model, and you have the serving part, the part that you just send an input of the data and you say, what is the chance that this is going to happen, and you get a number back. For the second part, the inference, streaming is a little bit more straightforward, unless you have a lot of processing to do on the data when it comes. For the training part, then you have to think about online machine learning models, and these are really, really tough to have. So usually what happens is that I think I've never seen an online learning model running in production, but the ideas and the articles on this is that you kind of have a model that updates itself, so the endpoint will always be the new endpoint according to the things. So you may have a cluster on a Kubernetes or something with 3 pods or 4 pods or 5 pods, and it's coming something, retraining, and after it finishes retraining, it already has the new input. So at every new point, it already generates something new, but I've never seen running in production because online machine learning models are not that scalable yet. Thank you.
Okay, thank you very much. Any other questions? Okay, thank you very much, Thiago.
Thanks, Ahad.